Okay, guys and girls, we have a weird schedule this week, obviously. All right. As far as this class goes, so we have class today, obviously, and then we have it on Thursday. Still with me?
Yeah.
Then we have Monday, Tuesday, Wednesday, Thursday, Friday next week. Still with me?
Yeah.
And then we have Monday the following week. This will be Chapter 8 test. Tuesday, Wednesday, next week, or 2 weeks, is final. Hey, Wyatt.
Hey.
Remind me to unmark you.
Okay.
That's baloney.
That's baloney?
Yeah.
I thought that we just take the Chapter 8 test.
No, but like this is supposedly the senior's last day, right?
Why would you
2 weeks
do
from
it on the last day?
Huh?
Yeah, you can't
That could be a
take a
mistake.
final on the last day.
That could be a mistake. Yeah, that'd be a mistake.
I don't know when else to do it.
Do it Monday, Tuesday. Don't do
Have the
Chapter 8
Chapter
test.
8 test part of the final.
Yeah.
All right, I'll have to think about
Monday,
that.
Tuesday.
All right, I'll have to talk with the
Yeah, 'cause I
people.
wanted to do a test on the last day.
Okay, I'm just saying.
That's what I did last semester.
I'm just saying. So, guys and girls, I will tell you this. Because Monday was a no-go day, and I'm not going to be that guy that says, no, you can watch my video online. Because, you know, when you get the people sitting there going, no, I don't learn that way. Going, it's raw video footage. It's just me in the classroom in a 2D rather than 3D spectrum. Kind of cracks me up. And I only say that because I've had that conversation so many times with students over all the years that I've videoed my lessons. Oh, I don't learn that way. It's just me teaching up here on camera. So, it's just kind of silly. So the long and the short of it, guys and girls, is I want to make this last unit good. And I think I can make it good. But we kind of have to you know, buckle down. And I'm not going to be that guy saying, look at all this that you got. My goal is this. We will cover 8.1 today. We will complete as a class 8.1's homework today. We won't do it tonight. Fair enough? Thursday, when we have the next class, we will do 8.2 in class, and we will do 8.2's homework in class as well. We will not have the homework. So I'm done giving you guys homework for the rest of the school year. I know most of you are going to cry yourselves to sleep about that, but I do need you on task. So if you're playing games on your phone or however else, you need to put it away, okay? So I'm on 8.1, and we got to go ready, set, and let's go. We cool? You ready?
Fire away.
Take a breath. Talk to me.
When are you in your office today?
Oh.
In a little bit. Probably not today. Tomorrow's much better.
Okay, because I
Perfect. Perfect.
What about
Tomorrow's much better for me. I'll be there like all day. All day. Like I don't teach in here at this building at all. I won't come into this building at all tomorrow.
so I could come in like before school tomorrow.
Yes, in my office over there. All right. Here we go. Shh. All right, so we are going to start the hypothesis test. So hypothesis tests, they come about just because you've probably noticed some sort of pattern, so you make an educated decision off of what you're seeing, go it over and over again. Or you have some data that you are able to look at. You're going to make some sort of statement saying, I feel this. Okay? So confidence interval versus hypothesis test. A confidence interval, create an estimate, an interval for which you think mu, which is the mean, is. Hypothesis test, you have a claim about mu that you want to check. Okay? So that you guys have been subjected to that kind of statistics for a long time. You know, those Trident commercials saying 4 out of 5 dentists surveyed say chewing, if you chew gum, chew Trident. You guys know this one? We're not going to go through that, but you've been subjected to this. So theoretically, you could create a test to see if this is a true claim by Trident. Or is it just some sort of advertising that had taken place just to get people to buy this particular gum? We still have problems that involve means or proportions. Okay, so that's no different. And then, so let's talk about the example. We've done this before. Do people speed on the damn road? Yeah, well, it says the speed limit is 40 miles per hour. but you think the average rate is higher than that. You sample 50 cars randomly and find their average speed was 48.2 miles per hour with a standard deviation of 4.3 miles per hour. Can you say that cars do speed on the damn road? I mean, maybe. I don't know. You know, did you just get really lucky to find those 50 randomly selected cars that you picked were the speeding cars? And I don't know. Okay? So, basic goal is, did the results, we get half of my chance. That's why I just said there was something going on here. Okay? So again, could we theoretically say, hey, I selected 50 cars randomly on the damn road. This is what my data showed. It showed they were doing 8.2 miles an hour over the posted speed limit. There was a standard deviation of 4.3 miles per hour. Did we just get lucky on that? So a lot of times we talk about the confidence interval, saying if we were to redo this test again, we feel with this much confidence that it could happen again within this, our average would fall within this region again, this slice of the normal curve. Okay, so let's talk about the null hypothesis. This specifies a population parameter of interest. It proposes a value for that parameter is our claim, status quo. So status quo meaning what is stated or expected or our initial hypothesis. So this is going to be how we label our initial hypothesis. H sub 0, H sub O, H naught. It's different ways that they refer to it. Okay? And then there's an alternative hypothesis. In the alternative hypothesis, we are considering the parameter of interest. Okay, so you make a statement and you say, hey, we feel this. This is going to happen. In our alternative, or HA, H sub A, we are going to do the same thing, but we're going to be this portion of the normal curve. So this would be a two-tail situation. Or if it was HA and we were saying, hey, we want to know what's less than this, then this would be our, that's going to be bad. Or one tail could be to the right. So you're still talking about areas that take place. Okay? So if you go through the little bottom thing, it says HA, the alternative hypothesis, our mean is greater than the number. That's going to be one tail. That would be to the right. Okay? Or if we said our alternative hypothesis, our mean is less than a certain number, then that's going to be one tail. That'll be the area to the left. But then it says our alternative hypothesis is not equal to the mean. So we're saying our mean's here, and if it's not equal to it, it's either on the region to the right or to the left. So that would be called a two-tail test. Two areas versus one area that you're finding. Okay, that's the same thing to do when you're talking about probabilities, but I'm not too worried about it. So two-tail means you're talking about two regions. A one-tail test, when you're talking about the alternative hypothesis, is either this scenario or this scenario. You have one portion that you're testing to state that it's true or not. Okay? Still with me? Am I going too fast? I'm sorry, it's late in the day. I'm like, crazy. All right. So, this chart that's below is fairly easy. It's easy to refer back to. So, okay, so what does this mean? It's just a Punnett Square. You've done this in biology. So you have H naught, that is true or false. H naught that we're rejecting, and H naught that we're failing to reject. This is where statistics starts becoming like the weird language of math, even though math is a weird language altogether. Because if someone were to come to you saying, we failed to reject our null hypothesis, therefore, and you're looking at them going, what? And that's the terminology that they'll start using. So, God bless you. Let's make it a little easier. God bless you. So, a type 1 error, if we had created a hypothesis and an alternative hypothesis, would go this way. The probability of rejecting H naught when it happens to be true. And a portion that are using is if you were to send an innocent person to jail. Okay? So, type 1 error, the probability of rejecting H naught, even though it's true. HL, yeah. Okay? I'm gonna try. That's why we're gonna do the homework together too in here. And I bet you in the homework it's gonna draw what we did here. Sweet. And then you walk out without homework. All right, type 2 error. Probability of failing to reject H naught when it's false. Probability of failing to reject H naught when it's false. So this would be sending a guilty man free. The person did it, he went free. Okay, so that's kind of the type 1, type 2 errors, and we'll refer to those often. And then the alpha is the level of significance, the probability we can use or decide to reject or fail to reject the null hypothesis is usually 0.05, which goes with the 95% confidence interval, 0.01, which goes with the 99%, or 0.001, which is the 99.9% confidence interval. Okay? So it's pretty deep where we went. Let me hit the examples, but we're going to refer back to the page prior. Okay, so we have a kind of a biased group here. Are Creek students smarter? Well, of course you are, because you're Creek students. Okay, are there those to argue with you? And this is trying to teach you that nuh-uh, yeah-huh is not the argument to win. Just because you said nuh-uh last doesn't mean you won the argument. Yeah-huh. Good. All right. The Colorado average on the ACT is 20.1. We took the ACT today as a junior class. Beautiful. Okay, so the Colorado average is on the ACT is 20.1. Now, I don't know if this is real information or that he just made up this problem just so we all feel a little better about ourselves. So it's a random sample of 35 Creek juniors. So we're sampling n equals 35. Creek juniors from last year showed an average of 23.6. So our average of our sampled population is 23.6. So right now, those who don't understand statistics can look at this and say, duh, we are smarter. But again, we need more proof to say that. Okay, and then we realized that this had a standard population or standard deviation of 2.9. So it says a random sample of 35 Creek juniors from last year showed an average score of 23.6 with a standard deviation of 2.9. Do we have enough evidence using a 0.05? So we're going alpha of 0.05 to say that Creek students are smarter than the rest of the state. Okay, so I think everything up here is known pretty easily. The state average is this. I'm going to cover that. I'm getting there. So everyone feels good about this. You can probably find the state average on the Colorado Department of Education website. It's not really necessary to go to. It's not that exciting. But I'm just saying you could probably find that information about any state if you went to that particular state's Department of Education website. Do you feel okay about me saying that? Now, I'm not trying to BS you. I'm just trying to say this is probably where you could have gotten this kind of information. Now, it's pretty easy that we could have gotten this information randomly from just our registrar over here or the counseling department over here. What do you think? Do you think that I could say, let's say there was, pick a number. Let's say there was 900 juniors that took the ACT last year. Can I say that? I don't know. That might be close. Is that okay to say? Okay, so let's say we have 900 juniors. We go to the registrar going, hey, how many juniors took the ACT last year? Like, let's look at, there was 900. Sound good? I mean, that sounds like legitimate information. And then we say, okay, I want to number those juniors 000 to 899, and I'm going to use a random number generator to select 35 of these people, and I want to see those scores. So you're sitting there with the registrar going, yeah, I got nothing better to do than figure out your data, but I'm building the schedule. But anyhow, we just got Ms. Luther, Adrian, us, our registrar's information saying, okay, I need student, and you plug in your number, I need student 008, so the 9th student on your list. Okay, that's so-and-so. What do they score? Okay, good. And then I go through and I do that for 35 students. Okay, I don't necessarily know who those kids are. I just gave every student a number, and then I use a random number generator to figure out how I was going to pick them. I ran my data. I put all my scores in my calc edit statistics. List 1, did a one variable statistics of list 1, and it told us our sample standard deviation is 2.9. That's stuff that we have done over and over and over again. Now, let's make sure we can figure out what in the heck does this new thing mean? What does this mean? Okay? All that means is we are using a 95% confidence interval. I knew you were going to say I love it. Because, I don't know. Because sometimes the math community is like, it's not a 0.05 test. And then other people come in and go, 95% confidence interval. Who sounds smart? I have no idea. I don't know why they do it. They just throw it in there like, hey, we're going to change things up. It's like, now we're going to take the number 3 and say that it really is the same thing as number 7 for the rest of our lives, which we know it's a lie. Okay, so what is our null hypothesis? Our null hypothesis. So remember, H naught is our null. HA, is our alternative hypothesis. Our null hypothesis is this. Colorado average equal 20.1. There you go.
Wait, so that's the null hypothesis?
That's our null hypothesis. Genius.
Okay.
It's always just the average.
No. So we're just taking this. So we're saying we're making our null hypothesis. We had this information that came to us from the State Department of Education telling us what the average ACT score was in the state.
I don't even think it's the
We're going to get there. We're going. We're taking everybody. We're saying, how did everyone do as a whole? This could have been as a nation. It could have been anybody who took the ACT, including that 9-year-old that scores a 36 his first time through. Okay, so our alternative hypothesis is this. Okay, so Creek scores are greater than 20.1. Huh? That's so remember the damn road example. Did I pick 50 cars at random and just happen to be that fluke situation? Did I pick 35 students at random that took this test last year at Creek and got a fluke score of 23.6? Do I know? So now we're going to test it. So we had a little bit of a We took scientific gathering of data, or better than just common knowledge, and we're testing it. Our hypothesis, Colorado is average is 20.1. Okay, we're saying that because it's coming from a bigger population. It's coming from like the whole state, not just the school. Okay, so. All right, let's see if we can make that jump. Now, it's not asked down there right yet, but would you feel that this would be a one-tail or a two-tail test? Two-tail or one-tail? Okay, let's go back to the tail.
Two-tail.
Let's go back to the tail.
Two tails.
Going back to the tails.
Two tails.
Okay. What is my null? Or what is my alternative hypothesis? Creek scores are here. That's what we're looking for. So what tail? How many tails?
One.
So one-tail test. You understand that?
What?
So it'd be two-tail if it was like less than this.
No, no.
Greater than this.
If I said Creek scores are not equal to this, that means it could be over here or over here. But I'm just trying to prove that we're smarter using our ACT scores to compare.
So if it's less than or greater than, it's one tail. Equal.
Yes. Or not equal to.
Or
Yeah.
not.
All right. There we go. Cool. All right. What would be a type 1 error? The type 1 error, so let's flip back. Says a type 1 error is the probability of rejecting the null hypothesis, H naught, okay, when it is true. So that's like saying an innocent man is being sent to jail. So a type 1 error here would be this. Colorado state average is not 20.1, but it does.
I'm sorry.
Wait.
Oh boy, okay. All right, so we're going to take our null, our H naught, and we're going to make it seem untrue. Okay, so remember, type 1 error, probability of rejecting H naught. If we reject H naught, we're saying that the Colorado average isn't 20.1.
So they made mistakes with that.
Or, just, was it a freakish year? Like, did the scores get released, or did the tests get released to schools before the test was given and schools got a hold of it? Like, did not really take place? Okay, so the type 1 error, probability of rejecting H naught, but when it's true. So this is like the thing saying an innocent man being sent to jail. Okay, so our type 1 error.
What do you mean by that? What?
Okay,
You just make the first hypothesis not true, even though it is.
yes,
Do the opposite of the null hypothesis.
you nailed it.
Okay.
You're good. All right, so we're just saying type 1 error. We're going to take H naught and make it untrue, even though we know it's true. That's just going to be, it's called a type 1 error. So Colorado state average is not 20.1. That's just type 1 error. That's just, how would a type 1 error take place? We're just putting it in there. What would it be? What would a type 2 error be? Colorado state ACT is believed to be 20.1, but actually is not. So let's say we have inconclusive evidence, so we think it's about this score, but we didn't really, so let's say we took 20 years worth of ACT data, and I said, let's take only 1 year's of it and we'll look at it. And now we're going to say, of those 20 years, or that 1 year, we had a 20.1 average. Oh, Colorado state average is 20.1. It's like, well, we have like other years we could look at. Okay? Does that make sense? So you're making a pretty good judgment call on a huge amount of data, but there might be other years that might reject it. Told you it's kind of goofy. All right. What is the probability of a type 1 error? Type 2. Colorado state average. ACT is believed to be 20.1, but it really isn't.
How is that a different answer?
All right. Well, I'll read it. All right. Type 1. Colorado state average is equal to 20.1, but it does. Okay. Type 2, Colorado state ACT is believed to be 20.1. So type 1, we're saying it is. Type 2, we're saying we believe. until age 15, Santa Claus is true.
How does that help me?
Okay, so I think that the type 1 error is just saying it's not true even though it really is. And then the type 2 error is saying it's not true because we don't like evidence it is. We don't, it's believed to be 20.1, but it's not. So the 2 is like a Santa Claus thing, so I think it is, but it isn't.
Let's move on. Let's see if we can backfill a few holes. Okay, so let's go back to the type 1 error. What is the probability of a type 1 error taking place? It's up on the board.
95%.
Almost.
5%.
So 0.05, which deals with the 5% confidence, 95% confidence. Okay, that was easy.
So there's a 5% chance of type 1 error.
Yes. Okay, so we're stuck on C and D, but we'll come back. We'll hit C and D here. We'll try and make it work. All right. So are we okay with letter A? Are we okay with letter B? I already know what C and D's answer is for most. Are we okay with letter E?
Yes.
Okay. Now, letter F. If we wanted to lower the chance of making a type 1 error, should we increase or lower alpha? So if I increase alpha, so if I made that 10%, that means it's a 90%. If I made it 15% or 0.15, that'd be an 85%. So we should decrease alpha to give us a higher level of confidence of correctness. Okay? So the less alpha becomes, the better our confidence interval becomes. And it changes from the person saying, well, I am 95% sure this is going to take place, to I am 99% sure this is going to take place. Okay. I know that C and D we still have questions on. So I need to find a few better examples to help you guys out to backfill those, and I will. Okay? All right, let's go to number 2. A researcher wishes to see if smokers have faster reaction times. Okay. She knows that the general population has an average reaction time to 6.3 seconds. So the general population is 6.3 seconds. Okay? What's that? Yeah, I'm just writing down some more information. With a standard deviation of 1.3. This is a weird example, but I'll go with it. And there was a certain test that was given to verify that these smokers had this reaction time. She administers this test, or people had this test. Then she administers this test to 12 smokers, okay, and finds that they have an average time of 4.9 seconds.
So everyone should smoke, right?
Sure. Yeah, I mean, does it really hurt you?
Obviously not.
Not to your reaction times.
So what if they already have slow or slow and fast reflexes before even if
That might be something to think about as far as the problem goes. All right. We have a 1% significance level, which is a 0.01. So our alpha is 0.01. So which confidence interval would this go with? There you go. This goes with a 99% confidence interval. Okay, because of that. Is that okay? Everyone still with me? Yeah. I know you're all trying to figure out if I'm trying to promote smoking or not. No, it was a problem that was written before I got here. Okay. Can she say a 1% significance level that smokers have quicker reaction time? Okay, what is the null hypothesis? Take a shot.
Is it that the average reaction time is 6.3 seconds?
Yep.
Hey, buddy.
Okay. Excuse me, I was smoking a little bit before I got here.
What?
I'm like the reaction?
Mrs. Action.
Is there reaction?
It's Mrs. Action.
Sorry. All right. Our null. Yes.
So would this probably be a two-tail because it has a smaller average like of the sample?
Haven't gotten there yet. It might be though. I don't know. We'll think about it in a second. Actually, I think we might be able to fill that in with what we say with our alternative hypothesis. What is ha?
The 12 samplers have reaction time.
Say it one more time.
The 12 samplers have reaction time of 1.9.
No.
They're less than 6.3.
It's that it's wet. It's that the
Yes.
average
Say it.
reaction time of the smokers is less than 6.3.
There you go.
So it's a one tail. One tail.
So one tail. Why is it one tail? Because we just want less than. We're not testing if they have a different reaction time. We're testing that they have a better reaction or a faster reaction time.
So if it was like, how can you tell if it's
If it were to say smokers have a reaction time that is not 6.3 seconds. So you don't know if you're looking above or below.
so you just say that it's not.
Yeah, it's not 6.3.
So then it can just be okay.
Because that not 6.3 would mean if this was where your reaction time should take place, if it's not, you have these two little pieces over here. But I'm looking for less, so it's going to be
It's
over
the
here.
other way. Okay.
And I was trying to make that work for you in your perspective, not my perspective. And I'm sitting there going, oh, my mind's going back.
That's me.
All right. Here comes our favorite. Let's see if we can chase this one around a tree. What would a type 1 error be? So we are going to do what with the null?
Make it not true.
Okay, so reject. Can we reject the null?
Yes.
Sure.
Can I reject? Hang on. Type 1. Type 1. What happens if I reject the null? Okay, so let's see, does that make sense on our thing? Could I reject the null for a type 1 test? It looks like I could reject the null. Okay, hang on. So H naught is true. The general population average is not 6.3. Okay, so reject the null, and we're going to say that this. So if we reject the null was reaction time 6.3 seconds. So I gotta reject that. That's baloney. What do you think?
Good.
You like baloney? If you like baloney. Oh, I thought you said something after baloney. What would a type 2 error be? Uh-oh, type 2.
The standard
Okay, let's see. Type 2.
believed to be. It could be 6.3.
So from our chart, type 2 error says fail to reject the null.
So it could be 6.3.
Am I there?
Yeah.
Fail to reject the null.
Fail to reject. So that means
General
that it
population
is
could
true.
be 6.3.
Failing to reject it is a double negative.
I know, but I'm just trying to tell you the language that they use. It's the maddening part of it. And so, I mean, if you walked home right now and you said, Mom, Dad, I failed to reject that I'm going to graduate, they're going to sit there for like 30 minutes going, we need to talk.
So then is it believed to be?
Okay? So we are going to accept, if I can spell, accept H naught. Because here I said I reject it. I accept. Can I squeeze this here? So H naught false general population average is 6.3 when it is not. Now you're going to yell at me again.
That doesn't make any sense.
Woo.
Literally, that is nonsense. That is not a sentence. What are you trying to tell me?
Could we just?
Love it. So C and D again are going to be our, so you'll find better ways of presenting C and D to you.
Wait, so they're saying, like they're saying that type 1's like they're saying that that's false, but it's actually.
Yeah, type 1 we're saying we're rejecting the null. So the general population average is not 6.3 when it was.
So like it used to be and now it's changed.
No, we're just saying that we are rejecting what the null says.
Okay.
Like you came across this data saying I reject that. I reject our null.
Like
But even though it was the true.
like you don't accept it.
Mhm.
Like you don't accept it, you didn't get into that solid. Okay.
Okay, the type 2 is we are accepting H naught. So H naught is false. General population average is 6.3 when it's not.
So if accepted, the fact that it's false.
This should make your brains hurt. It should piss you off a little bit.
Yeah, I'm gonna get pissed off.
All right. All right, so C and D again, we'll come back on those. So what is the probability of a type 1 error on this problem?
One.
Yes,
Point one.
we have that. So 1% or 0.01 is our probability that we have a type 1 error. So we have a 1% chance that we're going to have a type 1 error. Uh-oh. If we wanted to lower our chance in making, that should be a type 1 error, so change type 2 to type 1 error. We should increase or lower alpha. And we just answer that, we increase it.
Wait, what if it did also type 2?
We'll get there. We're not like that. All right, so 2 ways for H naught. Restate the population info, and then a new study of HA. I'm not going to read that. I'm not going to read that to you guys. All right.
On the homework you use.
Yes. Well, it's because we will build upon this. What time are we at here? Don't like, so I'll find out when the build is. Oh, 2. Okay. Problem number 1. I think we can get through problem number 1 and number 2. We with me? And then I'll be all your homework would be for the night. So we'll get it done. You guys ready?
Yeah.
Ready?
Yeah.
Okay, the medical community decides to study the issue of whether chemotherapy or radiation therapy is more successful for treating lung cancer. For the purposes of the study, they decide to use alpha value 0.10. So it's a 90% confidence interval. I love it. Okay. Can anyone decide if this is a one-tail or a two-tail right now?
I think it's a two-tail.
Okay, I like it. Why?
Oh, just
Because there's 2 options.
There you go.
like two.
It's as simple as that. It was nailed. 2 options. Chemo versus radiation. Okay, what is the null hypothesis? The null. Now I'm going to just write this. There is no difference between claims of chemo or radiation. Rad is radiation, if you don't understand my lingo. Is that okay? There's no difference between the claims of chemo or radiation. Let me ask you all this. We live in a state that there's something that is legal in this state that you can't take over lines because it's illegal. Do you think they're doing this kind of statistics to figure out whether dope weed is harmful or helpful? Marijuana.
Okay, yeah, well, thanks.
Mary Jane, pot,
I'm pretty sure you could call
homegrown.
it dope or call it weed. I don't think you need to call it.
Dope weed. Hey, if I'm going to throw a double negative. No, but do you think that this would be taking place? Do you think that the United States is looking to Colorado and going, huh? They just legalized that marijuana. That dope weed. Yeah. I think New Jersey is going to legalize cocaine here. Just to show everybody off. Yeah, we got cocaine legal here. I'm kidding.
Let's go to New Jersey.
All right. Our alternative hypothesis is there is a difference. Oh, there is a difference.
Good job. Yeah.
All right. If we reject the null, what is the probability that we make a type 1 error? There you go. If we reject the null, what is the probability we make a type 1 error? 10%. That. Okay, we're good there. What happens if our study makes a type 2 error? Uh-oh. Type 2 error is the one that you guys just hate me for this, but we'll deal with it. Type 2 error we're going to say this. Study found that there is no difference in treatment, but there was. Throw your eggs at me if you need to.
Wait, that kind of makes sense.
Oh, cool. Okay. Study found that there is no difference in treatment, but there was. Now, I know you all have grown up and you've heard two sides of so many different stories. Like, your dad had a friend, your mom had a friend, you know those kind of stories, or you had an uncle, dad. You guys with me on these?
Yeah.
You guys with me on that?
Yes.
You have an uncle, dad? I have a friend, dad. My best friend has an uncle, dad. No, we're not Tennessee. Third. No, what I'm saying is, there's always the claims. Like when I was a little kid, there was the fear of God put into us by our parents that if we lit off fireworks, we were going to blow off our finger because there was some kid that blew their finger off. But yet, I have yet in my life to have come across a child that was missing fingers due to fireworks of my upbringing. But yeah, shoot your eye out. Ricky Anderson had his eye shot out, but Lance Varney shot his eye out when we were in second grade. Okay?
Like what?
BB gun.
Oh.
Yeah, it was kind of gross. And so he had like a patch. But then during football, his glass eye would fall out, and you could clear a dog pile in an instant going. You'd sit there and be at the bottom of the pile, and you hear clink, 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 and you're like, that's my eye! And you're like, get off me! I can't move! And it's like on your cheek now. Sorry, reliving an old memory. Question?
So your statement in your we just said, I think I have this listed out. You just said the thing about the study was not truly true. Last example, would you repeat it?
The study found, this is type 2 error. Study found that there is no difference between the treatment, but there was. Go.
So, you're not disproving the
Listen, Winston's on it. Listen. Shh.
You're not disproving the statistics, you're disproving the studies. You're saying the studies are
I like it. You're not disproving the statistics, just the study. I like it. You guys missed it. That's the whole answer. All right. If we want to reduce making a type 1 error, should we raise or lower the alpha? We already know it's lower. And then, what are the risks of making a type 1 error for the medical community if we reject our null, but it happened to be true?
No.
Okay? So, I only got to problem number 1. I would like to go through problem number 2 on Thursday, but you don't have to do it. You with me?
Got it.
And I'll try and clear up C and D Thursday.